We already know that a scalar quantity does not have direction to be described, so it only needs magnitude to be described. Um, and we also know that a vector quantity has both magnitude and direction to be described. In physics, there is a particular way of describing the directions. Okay, so I'm sure you're very familiar with what is presented on the screen. So there is a Cartesian coordinate system. You already know that there is an x-axis. The horizontal line is the x-axis. You already discussed this in your pre-calculus class. And the vertical line is the y-axis. We also know that the positive x is east, and the north, the top, the positive y-axis north, negative x-axis west, and negative y-axis is south. And in terms of degrees, we already know, we already discussed this in your pre-calculus class, that 0 degrees east, this is our reference point, the east, or 0 degrees. If we rotate 90 degrees, that's north, so 90 degrees, and then 180 degrees for the west, and then 270 degrees south, and then if we complete one rotation, that's 360 degrees. Okay, we also know in your previous, maybe this is just a short review on directions. We also know that this quadrant here is the first quadrant. Okay, this quadrant here is the first quadrant. This quadrant here is the second quadrant. This is the third quadrant, and this is the fourth quadrant. Just a short review. Good. In physics, or in mathematics or physics usually, we can describe directions in 3 different ways. So we can describe direction first in terms of its reference. We can have a reference along the x-axis, so with respect to x-axis, with respect to x-axis, that means that our reference point is the x-axis, meaning east and west, or east or west. So that is why we can describe direction. We can say of east, or of west, meaning our reference is along the x-axis. So what are the directions along the x-axis? That's east or west. So that's the first way to describe the direction with respect to the x-axis of east and of west. We can also use the y-axis as our reference. So we can describe direction with respect to y-axis. Respect to y-axis. So what are the directions along the y-axis? So we have north and south. So that is why we can also describe the direction in terms of its reference along the y-axis. So we can say of north and of south, meaning it is with the reference to the north, with the reference to the south. And the last way, and this will be what we will use all throughout our discussions on vector, is particularly with vector addition, although I can also describe the direction in terms of the 3. So we need to convert later on in one way or another, convert directions into one reference to another. Okay? So we can also use the standard angle as our way to describe direction. I think this is discussed already in your pre-calculus class. So the standard angle. So we have 0, meaning the standard angle starts always from 0. So 0, and then 90, and then 180, and then 270, and then 360. So that's the standard angle, meaning our reference is always along the 0, the positive x-axis. So let's try to have a direction, and let's convert this direction into 3 different ways to describe the direction. For example, we have that kind of angle, that direction. What do you think is this? How are we going to describe this direction using the 3 different ways? We can also have, let's assume this is along the x-axis with reference to the x-axis. So let's just assume maybe 40 degrees. Okay, 40 degrees. That's just an assumption because somewhere between that's 45 degrees. So this is just an estimate. So let's say 40 degrees. So since this is with respect to the x-axis, so this is 40 degrees with respect to east. So that is off east because our reference is along the east. And this is going north. So that is 40 degrees north of east. Good. Okay, so again, the reference is along the x. But we can also describe this direction using the y-axis as our reference. So we can use the north as our reference. For example, this case, we can also use the north as our reference. If this is 40, we know this must be 50, right? Because the whole quadrant sums up to 90 degrees. So this must be 50 degrees. Now, since this is with the reference or with respect to the north, so it should be off north. And it is going to what direction? It is going to east. So that is east of north, 50 degrees east of north. Notice that if you add both, 50 plus 40, that gives us 90 degrees because that's the total angle in one quadrant. So if I say 40 degrees north of east and you say 50 degrees east of north, we are just describing the same direction. So if I ask someone, go 40 degrees north of east, and you also ask someone to go 50 degrees east of north, at the end of the day, they will just arrive at the same place. You are just describing the same direction. So now, how are we going to use standard angle? So this is the direction with respect to the positive x-axis. This is the direction with respect to the y-axis. So now we can also use standard angle for our direction. So that is just from 0 until here, move counterclockwise. And of course, this must be 40 degrees. So this is already our standard angle, 40 degrees. Okay, let's have another example. How about 30 degrees west of north? If I give you, that is the given angle, for example, that's 30 degrees west of north, what is the direction? Which quadrant will that be located? This is off north, meaning this is with respect to the north, with respect to the no, not x-axis, with respect to the y-axis, which is north. So from the north, going to the west. So from north, going to west, and that is 30 degrees. So let's assume this is the 30 degrees from north going to the west. So this is our 30 degrees. This is our 30 degrees west of north. If this is 30 degrees west of north, we know that this angle must be what? This angle must be what? This angle must be violet. This angle must be 60 degrees, right? 60 degrees, since the total, again, of one quadrant is 90 degrees. 60 plus 30, that's 90. So this is with reference to the west. So it should be off west, going to the north. So that is north of west. So you're just referring to the same thing. Now, if we are going to determine the standard angle, so again, the standard angle is from 0 until here. So what will be our theta? 0 until, erase ko muna ito ha. This is 30 degrees again. 30 degrees west of north. So if that is 30 degrees, what do you think is the value of our standard angle? Our standard angle must be what? It must be 120 degrees because this is 90, right? Plus 30, 90 plus 30, that's 120. So the standard angle is 120 degrees. There is no west of north, north of west when you use standard angle. So automatically, you know it's in standard angle because of the degrees. Good. Okay. Let's have another example. 80 degrees south of west. So meaning south of west, meaning our reference is the west going to south. So from west going to south, that's 80 degrees. So more or less, this one. So this is 80, for example. If this is 80 degrees, what do you think is our standard angle? This is 80 degrees south of west. Our standard angle is, again, take note, we are going to use standard angle all throughout our discussion later. Meaning our standard angle is from 0 until here. So from 0, so we know this is 90. We know this is 100, this is another 90, so that's a total of 180. So it's just 180 plus 80, that gives us what? 260 degrees. So our standard angle is 260 degrees. Another example. What if I give you 55 degrees south of east? Which quadrant do you think that is? So that's 55 degrees south of east, meaning it is located along the east. It is with reference to the east going to the south. So from east going to south. Good. So that is our 55 degrees. This is our 55 degrees south of east. So what do you think is the standard angle? Our standard angle. Are we going to add? No, of course, we're not going to add because the 55 degrees, this part here, we know this is 360, right? 360. If we complete one rotation, that's 360, but we only need this portion. So that's 360 minus 55, right? So that you can get this portion. You know that total rotation is 360, but you only need this part. So that's 360 minus 55. It will give us 305, right? Yes, 305. Theta is 305 degrees. Sir, what if we use direction with respect to the south? Of course, you already know that if this is 55 degrees, you know that this must be 35 degrees, right? So that's 90 minus 55, that's 35. So it is east of south. So that's how you convert directions. That's how you describe the directions. Good. Let's have an example. Let's assume this is 28.2 degrees. So we know this is east of south because that's coming from the south going to the east. But again, when we will discuss later all throughout our discussion on addition of vectors, we are going to use the standard angle. Good? We are going to use the standard angle. So what do you think is the value of the standard angle? So from 0, 90, 180, 270, this one. We know this is 28.2, so it must be 270 plus 28.2 degrees. Good. Okay, and that gives us 298.2 degrees. That is already our standard angle, 298.2 degrees. Is that clear? Okay, another example. This one. If this is 35.1 degrees, of course, we know this is north of west, right? North of west, because that's coming from the west going to the north. But again, when we will solve later on in vector addition, we are going to use standard angle. So therefore, our angle is from 0, we know this is 90. What do you think the angle? So we know this is, the total is 180, but we only need this part of the total. So that's 180 minus 35.1. And that gives us what? 146.9? I don't know. Let me check. 180 minus 35.1. 144.36. 144.9 degrees. So that's already our standard angle. Good. Or if you want to know this portion, if you are going to know this portion of the angle, you know this is how much? 35, 90, that's 90, 60, not 64, 54 point, 54.9 9, 54.9 degrees. Okay, another example. That is 85 degrees. So this, we know this is west of south, because it's from the south going to the west. But again, for our discussion later on, we are going to use standard angle. So when we talk about standard angle, that's from 0 until you rotate. You rotate from 0 to this one. So we know this is 180 until here. We know 270 until here. So you just subtract 270 minus 85. Or this is, we know this is 5 degrees, right? 85, that's 5. So automatically, that's just 180 plus 5. Okay? So just a little bit geometry. So, of course, we know this is 100. This must be 185 degrees. Is that clear? Okay. Another. That one. So if this is 31.5 degrees, we know this is 31.5 degrees east of north. So what is our standard angle? Our standard angle is from 0, rotate to this one. That's our standard angle. So if that is 31.5, we know that our theta is what? We know this is 90, so you just subtract 31.5 from 90, and that gives us 58.5. Let me check. Sometimes I doubt. 90 minus 31.5. Yeah, 58.5 degrees. So that's already our standard angle.